Hello, everyone, and welcome back. This is Mr. Cobalt, and in this video, I'm going to be showing you how you can use the periodic table to identify the number of valence electrons and how to figure out the charge. So let's get into this. So here's the periodic table. You probably have one yourself. You can write this down on your periodic table as well. I'm sure your teacher already had you do this, or maybe will have you do this. So, with regard to the periodic table, um, we can number these as your periods. So, we number down the period here. So, we start with 1. So, that's period 1. Row, we call these rows periods. So, this is period or row 1, period 2, period 3, and period 4. And so we can number these 2, 3, 4, 5, 6, 7. And across the top, your periodic table might be already numbered, but they can be numbered a couple of different ways. The first way is just 1 through 18. So we have 18 different columns here. These columns are called families or groups. So what we're going to do is we're going to number them one way is you could number them across 1 to 18. So this would be 1, 2, and then if we do 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then up here we do, I'm going to go up here. So 13, 14, 15, 16, and 17, and 18. So that's one way that they number the groups or families. But a second way is where they use A and B notation. So you can number them as families or groups A or groups B. And the B groups, which I'm not going to get into in this video because how they number the B groups is a bit strange at first, right? So they don't really go in numerical order like you would think. This group here is referred to as your B group, right? So this would be your B. So you'd number these 1B through 10. So we have 1 through 10. So these would be 1B, 2B, 3B, but they don't really go in the order. You'll see in periodic tables that they move things around, but I'm not going to get into that. Just know that these groups here are referred to as the B groups, and these are the transition elements. So this middle part is called the transition elements. These are your B group elements. And then your main group, so let's write this down. These are transition elements. And these are your main groups. So groups 1 and 2 and 13 through 18 are your main group elements, and those are we call the A group. So the way they're numbered is 1A, 2A, so 1A and 2A. And then jumping over here, you have 3A, 4A, 5A, 6A, oops, not 6, 8, 6A, 7A, and 8A. So these are the main groups. So I'll write that main group elements. So these would be the main group. And then over here we have main group elements. And so the main group elements are labeled the A groups, and your transition elements in the middle, also known as this D block of elements, are the B groups. So we are going to focus on the A groups, the main group elements. And there's a couple of things that you should know about this numbering. First, the side numbering here, the numbering of your periods corresponds to energy levels. And that is the number, if you're looking at the Bohr model of every atom or every atom in this row would have one energy level in their Bohr model, right? So they would have one orbit, right? And then if you went to the second period here, all of the elements in the second period would have two energy levels or two orbits around their nucleus. So second energy level, third energy level, fourth energy level. So these numbers correspond to the number of energy levels you'll find in those atoms at that level. So all of these atoms would have 4 energy levels. All of these would have 5, and so on. So these numbers correspond to the number of energy levels you'll find in the atom. Okay. And in a future video, what I'll do is I'll have a electron. I'll have a periodic table with Bohr atoms, and I'll show you how that's laid out. The thing that you want to remember here is that the group numbers represent the number of valence electrons. So let me write that down. So valence electrons. So if you're, I should point this arrow to the A groups, right? So the A groups, those A group numbers correspond to the number of valence electrons you'll have in that particular element, or the elements in that particular group. So if you're in group 1A, you have one valence electron. So all of these have one valence electron in their outer shell. If you're in group 2A, then you have two valence electrons in your outer shell. And then if we skip over to 3A, so 3A would be 3 valence electrons. So all of these elements, boron, aluminum, gallium, and so on, all of these have 3 valence electrons. And so remember, the valence electrons are the electrons in that outermost shell, which we call the valence shell. So that outermost shell, the shell that has electrons that is farthest from the nucleus, that is your valence shell. And so the number of the group you're in tells you the number of valence electrons. So if you're in group 8A, you're a noble gas, that is going to have 8 valence electrons. And 8 valence electrons, with the exception of helium, helium only has 2 valence electrons because that first shell, that first energy level, can only hold 2 electrons maximum. That these elements are stable, so they have a full outer shell. So for helium, that full outer shell is 2 electrons. For the rest of them, that full outer shell is 8 valence electrons. Okay, so now that we have an idea of the number of valence electrons, we can look at the periodic table and identify what the valence electrons are for each element. We can think about the charge of those elements. So we got to move to a different periodic table, so I have more room to work with here. So here is another periodic table. So same as before. So here I have the A groups labeled. And so now we can kind of look at and figure out what the charges would be for different elements in the main group. So if we know that the groups in here only have one valence electron, then we can figure out, okay, is it going to lose or gain electrons? So you got to remember that the atoms here want to be like the noble gases. right? So elements here want to be like the noble gases. And so these elements, all of these elements, actually elements in general want to be like noble gases, because as I said before, the noble gases are stable. And the reason that they're stable is because they have a full outer shell. So the other atoms want to have a full outer shell as well. So they're going to do that either by losing electrons or gaining electrons. And so since these elements here have one valence electron, they could either gain they can either gain 7 electrons, right? So if you look at lithium, right, lithium has one valence electron. It could either go all the way to neon. It could gain 7 electrons and be like neon with 8 electrons in its second shell, or it could just lose that electron and just have that outer shell, the first outer shell, full. And so it's easier just to lose that one electron. So by losing that one electron, electrons are negative, and so you no longer have an electron that is balancing the charge of the protons in the nucleus. So if you lose that electron, you have a positive 1 charge. So that means that you're going to have a 1 plus charge on your atom. So all of the elements in here are going to have a 1 plus charge. So you can think of the same way here for your elements in this group. So these elements all have a second two valence electrons. So they can either gain 6 more electrons to be like these elements here. Like so beryllium can either gain 6 electrons and be like neon, or it could lose 2 electrons and be like helium. Magnesium could gain 6 electrons and be like argon with a full outer shell, or magnesium could lose those 2 electrons in that shell, in that third shell. So let's label this again: 1, 2, 3, 4, 5, 6, 7. Right? So magnesium could lose the 2 electrons in that third shell and just have a second shell that's full, like neon. So what you want to do is you want to look for the noble gas that is closest to your element, right? And that's the noble gas that that element is going to want to be like. So here, if you look at magnesium, you could either go to argon, which is 6 away, or you could go back to neon, which is just 2 away. So neon is closer. So magnesium is just going to lose those 2 electrons in the third shell and just have a second outer shell. The second shell be the full shell. So then magnesium will have a plus 2, a 2 plus charge. And so that goes for all of the elements in group 2A. So that's going to have a 2 plus charge. And you could do the same thing for the 3A. So 3A elements, you could either go 5 towards neon for boron. If we're looking at boron, you could either go 5 towards neon, or you could lose 3 and just have an outer shell number 1, the first the first shell be full. Or you could gain 5 more and have the second shell full. So since boron is closer to helium, it's more likely to lose those electrons. Same for aluminum. Same for this group. So this would the elements in this group are going to have a 3 plus charge. We're going to skip 4A for a moment, and we're just going to go to 5A. Now 5A, these elements here, now if you look at, say, so for example, phosphorus has a partially full third energy level. And so phosphorus could either lose those electrons to be like neon and have a second energy level full, which is the next lower one, or it could fill up the rest of the third energy level and have a full shell like argon. In this case, it only needs 3 more electrons to be like argon, whereas phosphorus would have to lose 5 electrons to be like neon. So in this case, it's much easier to gain those 3 electrons than to lose 5. So it's going to gain those 3 negative electrons. So that's going to be a 3 negative charge. So elements in this group tend to gain 3 electrons in order to have be like a noble gas. And that'll give them a 3 minus charge. Same thing for this group here. So oxygen, sulfur, selenium. These guys here, if we look at selenium is 2 away from krypton. So it could either gain 2 electrons to be like krypton with a full outer shell, or it could lose 6 electrons to be like argon, sort of, and so be stable that way. And so that would be a lot harder to do. So selenium and sulfur and oxygen, these elements will tend to gain 2 electrons. So gaining 2 electrons will give them a 2 minus charge. And then with these elements here, the halides, right? So these guys, fluorine, chlorine, bromine, iodine, these are the halogens, or they form halide ions. The halogens are only 1 away from these noble gases, so all they need to do is gain 1 electron. They're not going to lose 7 electrons. That would be too much. So they can just easily gain 1 electron and be like the noble gas that's closest to them. So fluorine will be like neon. Chlorine will gain an electron to be like argon. Bromine will gain an electron to be like krypton, and so on. So all of these in this group will have a -1 charge. And these guys already have, the noble gases already have a full outer shell. So they're not going to gain or lose electrons. They're already stable. They're happy the way they are. So they're going to have a 0 charge. Okay. So that's how you can figure out the charges. Now, coming back to this group here 4A kind of stands in the middle. So it looks like they could gain 4 or lose 4. So it would be a plus or minus 4. And so this group we kind of ignore because it's hard to tell whether it's going to have a plus or minus. So we tend to ignore these. But the rest of these are your typical charges for each element. So you could figure out what the charges are pretty easily based on what group they're in. Now, there's a couple of rules or ways you can remember this. So one thing to remember is for your positive ions, for groups 1 through 3. So groups 1A through 3A, the positive charge is equal to the group number. So if you're in 1A, you're positive 1. If you're in 2A, you're positive 2. If you're in 3A, you're positive 3. Okay. For groups 5A through 8A, the rule to remember, so for groups 5A through 8A, the rule is that the negative charge, the group number, I'll write it this way, the group number -8 equals the negative charge on your atom. So if you're in group 5A, the group number is 5, so 5 minus 8 is -3, so you have a -3 charge. If you're in group 6, group number is 6, so 6 minus 8 is -2, so we have a -2 charge. 7A, 7 minus 8 gives you a -1 charge. Group 8 minus 8 is 0, so they have a 0 charge. So this holds true for groups 5A through 8A, and this holds true for groups 1A through 3A. So that's an easy way to remember. But the best way to remember this is just to know what's going on. What's going on with the atom here? And that's where you have to think about the number of valence electrons that the atoms have, and that they want to be like noble gases. And so they're either going to lose or gain electrons to be like the closest noble gas. So whatever noble gas is closest to your element, you got to think about, okay, what is it going to do to get to that element? Is it going to gain or lose electrons? And then the number of electrons it loses is going to be the positive charge. The number of electrons it gains is going to give it negative charge. I hope this was helpful. If you enjoyed this video, if this was a learning experience for you, please smash that like button, subscribe to my channel, hit that notification bell so you can be notified by the other videos that I post. Please put a comment in the comment section. Let me know what you think, and if you have any questions I can answer. Thanks for joining me. Have a great day.